Have you ever just sat and wondered, what's the most powerful earthquake that could possibly happen? I mean, we hear about magnitude 7s, 8s, even 9s, but what if you just keep going up the scale? Well, we're going to dive right into that, all thanks to a listener, Alex, who asked a question that's going to take us to the absolute limits of energy and imagination.
So there it is, a magnitude 15. I mean, is that even a real thing? What on earth would that be like? Well, to answer that, first, we got to get our heads around the scale itself, because it almost certainly does not work the way you think it does.
Okay, so here's the most important thing to know. The scale we use today, the moment magnitude scale, isn't some simple ladder from 1 to 10. It's logarithmic. Now, what that means is that going from, say, a 6 to a 7 isn't just one step up. It's a release of about 32 times more energy. And even more important, there's no top and there's no bottom. It's designed to measure, well, anything.
So with that in mind, let's start climbing that scale and see just how wild things can get. We'll start with a number that's already powerful enough to literally reshape our world. A magnitude 9. You know, the massive earthquakes we've actually seen, like the ones in Sumatra and Japan this century, they were right around here. These things were so powerful, they physically changed the speed of the Earth's rotation. They made our day just a tiny, tiny bit shorter, but in a way we could actually measure. That's our starting point. All right, let's jump up to a magnitude 11. For an earthquake like this to even be possible, you would need a single fault line to rupture that stretches halfway around the entire globe. As you can guess, our planet just isn't built that way. A magnitude 11 is physically impossible on Earth. But Alex asked about 15. And here it is, the answer. A magnitude 15 earthquake would release enough raw energy to boil and evaporate every single drop of water on the planet. All the oceans, all the lakes, all the rivers, just gone. Hey, I guess the good news is, if that happened, we wouldn't have to worry about tsunamis, right?
Now this is where it gets really fun. A magnitude 18 quake, that's enough energy to overcome a planet's gravitational binding energy. That's just the sciencey way of saying it's the minimum energy you need to completely tear a planet apart against its own gravity. Blow it to bits. So yeah, when the Death Star zapped Alderaan, it was basically causing a magnitude 18 earthquake.
And believe it or not, we can actually go higher. The most powerful quakes we know of happen in these super dense things called neutron stars, and they can reach around a magnitude 24. To try and picture that, imagine filling the entire planet Jupiter, top to bottom, with hydrogen bombs, and then setting them all off at the same time. That's the energy we're talking about.
And that brings us to the end of our violent, explosive journey up the scale, a magnitude 25. An earthquake so ridiculously powerful, it would release enough energy to overcome the sun's gravity and just unbind it. An exploding sun. That's about as big and destructive as it gets.
Okay, so we've spent a lot of time talking about huge, violent, world-destroying events. But remember what I said at the beginning? The scale has no top, but it also has no bottom. So let's flip this whole thing completely on its head. What does the other end of the scale look like?
And this is where things get really fascinating, and honestly, a little weird. We're about to head into the world of negative numbers, measuring tremors so incredibly small, they're happening literally all around us, all the time, and we don't even notice.
So let's just get this out of the way. Is a magnitude 0 earthquake a real thing? Oh yeah, absolutely. But that is not the floor, not even close. As you're about to see, the scale goes way, way lower, measuring energy so tiny they almost sound like poetry.
All right, let's see how these tiny, tiny quakes stack up. We'll use some examples of things that might happen right in your own house, from, football players to feathers. Okay, let's walk through this. A magnitude 1, that's like a cement truck being dropped on the street outside. Definitely noticeable. Now, a magnitude 0, the entire Dallas Cowboys football team running full speed into your neighbor's garage. At -1, it's just one player hitting a tree. See how fast that energy drops? By magnitude -2, we're talking about a cat falling off a dresser. And a -3, it's that same cat just knocking your phone off the nightstand.
I love this one, because it shows you just how sensitive this scale is. A magnitude -5 tremor has about the same energy as pressing a key on one of those old, heavy, clicky mechanical keyboards. But the gentle tap on your modern laptop keyboard? That's a magnitude -6. We are measuring unbelievably tiny differences in energy now.
And here we are, magnitude -7. This is the energy equivalent of one single feather, fluttering down and landing softly on the ground. Just think about that for a second. The very same scale that measures exploding suns also measures this. It's incredible.
Let's take our last few steps down this rabbit hole into a realm of tremors so small they're barely even there, existing right at the very edge of silence. A magnitude -8. We've now reached the energy level of a single, fine grain of sand making that tiny little click as it lands at the bottom of an hourglass. It's almost a purely conceptual amount of energy.
And that brings us all the way down to a magnitude -15. The exact polar opposite of Alex's question that started this whole thing. The energy released here is the same as a single mote of dust after drifting around in a sunbeam, finally coming to a gentle, quiet rest on a tabletop. From boiling every ocean on Earth to this.
And you know, I think that's just a perfect place to end. We went from the Death Star to a dust mote, all on one continuous scale. It's just a powerful reminder that the most amazing journeys aren't always about cosmic-level destruction. Sometimes it's about appreciating the quietest, most subtle energies in the entire universe. And really, after all that talk of exploding planets, sometimes it's nice not to destroy the world for a change.